Okay, so what did I tell you the first step should have been?
It's not this?
Close. You should be doing what? You should drop that cosine term because that's what makes it alternate.
It's just a of n.
Uh-huh.
That equals 0.
Good.
Now we see if just the a of n is decreasing. So we're going to take the derivative. Or we could just see if a of n is less than greater than a of n plus 1. Let's see here.
So you can see how that method is much easier in this case, right?
Yeah, it's all circumstantial.
Otherwise, you'd be doing a chain rule. Within the chain rule, you'd be doing a product rule.
That would take too much time.
Yeah. All right.
So now we need since the AST passed those two tests, we just need to test if it's conditionally convergent or actually convergent.
Okay, and again, only if they give you those exact wordings. Okay. Otherwise, it's convergent if we're just doing AST. But if they say determine conditional convergence or absolute convergence, then you need to.
Okay then.
All the way with it.
All right. There you go. Okay, now I'm stuck.
Okay, what's the problem?
I have no idea. Wait a second. I know I need to do integral test here.
Okay, so what do we need to write down first? The moment you realize it's integral, check three things.
Let's see here. Is it from 1 to infinity? It is continuous.
Huh?
We can see from it that it is positive.
Mm-hmm.
And we already tested that it was decreasing.
Good.
So we can do the integral test on this.
Good.
Okay, that explains where the 1 over x comes from. 1 plus ln of 2x. All right, I got this.
I'm sorry, I was texting the next student.
When's the next student?
It's supposed to be at 7, but
Well,
he's not here. We're going to keep working until he's here. All right, so what are you doing now? Good.
well, I'm just.
So I don't see any formal work though. What are you missing?
I'm missing the u.
Uh-huh. U equals and then du and solve for du and all that, or dx. Plug it in.
But using the u means I have to change the integral, doesn't it?
Uh-huh. Unless you want to do the indefinite integral, get the answer, and then plug in plus the balance. Usually I say don't do that, but on an improper integral like that, I don't mind. It's up to you, whatever you want to do.
I think I'll just do it the long way this time. Let's see here.
Is that going to change? Is b going to still approach infinity?
Yeah, b doesn't approach infinity. Well, let's see. As b approaches infinity in the u, it still approaches infinity.
Yeah. So.
And you put 1 in here, it's just 1 plus ln of 2.
Good.
So
don't forget the limit. Okay.
B. And that's just 1 plus ln of 2. It becomes 1 over x square root of u x du.
Good.
The x's cancel out.
Good.
And it becomes limit of b approaching infinity from 1 plus ln of 2 to b of u raised to the negative 1/2. So we can integrate this by adding 1/2.
By adding what?
By adding 1/2 to the by adding 1 to the power.
I think your brain was ahead of itself. It gave you the answer.
Yeah, weird. And we drop down 2 because we're dividing by 1/2. 2u raised to the 1/2 of 1 plus ln of 2 to b, which is still the limit b approaches infinity. And since infinity's on top, we do infinity first. So 2 square root of b minus 2 square root of 1 plus ln of 2. I know it's a bit scrubbed up there, but the answer is still going to be infinity, so it diverges, which ultimately means that this function is conditionally convergent.
Because you're going to get what?
Because
Okay, yeah, I didn't see that part. I'm sorry. Good. The student's not coming right now, so we're good. Keep going.
Okay, conditionally convergent because it passes the AST, but fails the integral test. Would that work as an explanation, or do I need to be a bit more detailed?
No, that's about as good as it gets, buddy.